Hello, students. So we are going to review the answers and the strategy to answer these type of questions. So I'm going to go ahead and start with the first one. And answer this question. I believe it's only one question. Which two responses are characteristics of physical chemical changes? So we want two responses of physical chemical changes. So a physical change can change back into what it used to be. It's basically just broken up. Can return back to its normal self. Sometimes the process may be a little difficult, but it can be turned back into the original ingredients or original elements and compounds. All right, so let's look at the answer choices. Can change matter into another substance? No, that would be a chemical change, so that's not going to be our answer. Can be returned back to its original state of matter? Yes, this is true of all physical changes. A broken up cracker is an example of a physical chemical change. Yes, that is correct. It cannot be returned back to its original state of matter. So no, that's not gonna be it. So these are the two responses of physical changes. All right. So I think that's it for that question. And I'm going to move on to the next one. Let's see here. Let me go back to the Friday folder. Okay, this one has two questions. Evidence of chemical changes are all except. Now remember, chemical changes means it's changing into a different substance. That's all. That's one thing we got to remember. And it cannot be returned back to its original self. Also, evidence of chemical change is it gives off a little heat. So these are all the things that I know about chemical changes. And that's what you should do when you read these questions. Before you read the answers, think about everything you know first. And it makes it easy to find the answer that way. So now we're just going to find something that's similar to what we just said. Evidence of chemical changes are all, okay, when two or more substances are mixed together and a color change occurs. Okay, yes, you can get that from the study guide, so that's true of a chemical change. When two or more substances are mixed together and an odor occurs. Yes, this is also true from our study guide. If you're looking at your study guide, I'm looking at it right now, yes. There's a little skunk in the glass. When two or more substances are mixed together and a new substance is produced, yes, that would be kind of like a substrate. And the next one says when two or more substances are mixed together and they can be returned back to their original state. Okay, that sounds like physical, because only physical changes can return back to their original state. So all our evidence except this one right here. All right, so that's the answer to that one. I opened the wrong one. Okay, so number 2. All right, so this is a match one. And I actually had an error in this, I just fixed it. The error was sublimation. Sublimation is when the dry ice, the gas leaves, and this gas actually can be turned back into dry ice. Good example of this is a fire extinguisher. If you take a fire extinguisher and you shoot it into a pillowcase, hold the pillowcase real tight to it, and shoot all the fire extinguisher out to the pillowcase, it actually makes dry ice. So basically, dry ice is just CO2. So, by the way, don't do that because it's very expensive to replace those. And if you did that at a building, you're probably going to get in trouble for it. I believe it costs about $40 or $50 to refill each one of those fire extinguishers. All right, so this is going to be a physical change because it can return back to dry ice. All right, so let's start for some ones that we know. Melted ice is an easy one. You could just remelt the water and get ice. So that's going to be a physical change. I like to do the easy ones first. So that actually is a strategy for these type of questions, to do the easy ones first. These two are going to be physical. Torn pieces of paper and broken up cracker. Those are easy. Those are physical. Because the substance has not changed, it's just rearranged, I guess. Broken or torn. What's another easy one? Fire is always kind of confusing. Ooh, temperature change. That's always a sign of a chemical change. All chemical change leaves some type of evidence of heat. And the reason for that, by the way, is that it's not a very efficient change of energy, so it leaves a trace of heat. Anytime energy transformation is not efficient, it leaves heat. So if you feel heat on an engine of a motor, that's because it's not really good at transferring the gas to energy. There's a lot of waste. The waste is heat. All right. Thought that is an interesting side note. Okay, so let's look at what's left. Melted butter. Yes, if you take melted butter in a dish and put it back in the freezer, it will harden back to butter. So that is true. So that's going to be physical. When you mix two chemicals together, liquid chemicals, and they make something solid, and I've seen YouTube videos of this, and I can't think of one exactly, but if they make two solids, I believe there's a YouTube video called Elephant Toothpaste, and that is two liquid chemicals making something solid. And that would be a chemical change, because we won't be able to turn the solid back into liquid. It's probably a hard one, I bet, for you guys. Rusted nails, that's always going to be chemical, because no matter what you say, whether you sand it or not, a rusted nail cannot be returned back to its original self. The rust actually eats away the metal, so can't return back to itself if metal is eaten away from it. So rust is a chemical change. And anything cooked is a chemical change, because we cannot turn this cooked egg back into an egg again, not ever again. So that is a chemical change. So once you get the hang of it, it's pretty easy to kind of figure these out by asking those two questions. Can you turn steam back into water again? Well, the answer to that, if you were to put a glass lid on here, you would see all the water on the lid. So yes, you can turn steam back into water again. So that would be physical, because it can be turned back to its original self. You mix two chemicals and the color changes. This is kind of a tricky one, because you mix two different chemicals and the color changes, that's one thing, and then it would not be able to return back to its original matter. But what about Kool-Aid? So if you had Kool-Aid and you put the Kool-Aid mixed in water and it turns red, can that return back to its normal self? And the answer to that is yes, because Kool-Aid is a mixture, not a chemical change. If you're just mixing red dye with water and sugar with water, and you can remove the dye and the sugar by boiling it and getting the water back. But that's not what we're talking about here. We're just talking two chemicals, chemical A, chemical B, and all of a sudden it makes this new chemical, chemical C. So this would be a chemical change. We mix two things together and there's an odor. Like for example, you put your feet into your shoes and there's an odor. Is there a chemical change occurring? Yes, because if there's an odor, it's a sign of chemical change. Okay, we did sublimation, that's dry ice. And these two, okay, anything cooked is chemical. And this is probably the absolute hardest one for everyone to understand. Fire is chemical. Think about it, because no matter what you burn, whether it's wood, a paper cup, or whatever, you can never return the ashes back to its original self. So fire is a chemical change. And also remember, evidence of chemical change is heat. Fire does give off heat, so that's another reason that it's a chemical change. All right, hope this helped. We'll go on to the second question. Well, that was the second one. So we're almost done here. Let's see. Right here. 2 questions here. Which of the following is a chemical change in plants? Okay, there's only a couple of chemicals that come to my mind. And this, again, this is a strategy to answer this type of question. Think about what you know about what you're reading. The more you can say in your head, the easier it is for you to find the answer. Never look at the answer choices yet. At this point, you don't want to cloud your knowledge of what you're reading and what you know. So let's think about it. Chemical changes in plants. Okay, we know about there's the glucose in the plant, and that glucose creates energy. So what are some other chemicals changes in the plant? Well, the whole photosynthesis thing is all about chemicals. There's water, that's a chemical, that's H2O. There's carbon dioxide that it gives us, that's a chemical. There's oxygen that we give the plants as a chemical. So there's a lot of changes going on, especially when we give a plant water, we give it oxygen, and we give it radiant energy from the sun, and that gets changed into oxygen. There's a change right there. Hear the word change? That gets changed into oxygen and energy and a little bit of water. That's what answer is close to that. Which of the following is a change in chemical change in plants? The product glucose from photosynthesis. Product means it's the end result, what it's making from the chemical change. That's a possible answer. I like that. But let's see if there's another answer, because sometimes you have to make the choice of the best of 2 possible answers. Phototropism is plants growing towards the light. That has nothing to do with chemical changes. Thigmotropism is plants growing around a pole by touch. Again, that's nothing about chemical changes. These 2 topics are unrelated, and geotropism is unrelated. These are all our plant stimuli examples, and this is a chemical change indeed. So our answer is going to be the chemical change in plants is the product glucose from the photosynthesis formula. Okay, number 2. All tropisms are physical changes. Okay, tropisms is the way plants move. Okay, plants move towards the light. Plant moves, roots move towards the earth. Plants can grow around a pole through thigmotropism. Are these all physical changes? Yes, because they can be all undone. They can all be undone. You can remove the plant from the pole. You can pull the plant off from the ground. You can unbend the plant. These are all physical changes, so the answer is true. All tropisms are physical changes. Okay, now we're down to our last one, everybody. And, ooh, there's a lot of questions in this one, so we'll try to get through this real quick. Okay, teeth breaking up food in smaller pieces is known with what type of digestion? Now, the word physical and chemical are always kind of interchanged. So when you see mechanical digestion, they could also be talking, that's the same thing as saying physical digestion. So teeth breaking up the food, is that physical or chemical? And I know you're going to tell me that it's physical. So this is going to be the answer, mechanical digestion. Mechanical means the same as physical. Saliva gland secreting amylase as a chemical on the food in your mouth, which breaks down the food into glucose. Okay, chemical breaking something down, something totally different, glucose, that has to be a chemical change. The muscle contractions of the muscles of the esophagus has a scientific name. Okay, and you just have to know this. It's not homeostasis. We know that's the well-being of your body. It's not paralysis. Paralysis is when you can't move when you're sleeping. You wake up out of a bad dream and you can't move. The correct answer is peristalsis. Peristalsis is the muscles contracting automatically, moving the ball of food down your esophagus. Number 4, almost halfway there. Type of digestion that occurs in the esophagus. Is it going to be chemical, mechanical, amylase digestion, or acid digestion? Okay, these two we've never heard of. So those are not going to be possible answer choices. So it's either going to be chemical or mechanical. Now remember, esophagus, that's muscles contracting, moving a ball of food down your esophagus or your throat. So that's definitely going to be physical movement. So that's our answer is going to be mechanical digestion. All right, now we're halfway there. Type of digestion that occurs in the stomach. Okay, there's a lot of chemicals in the stomach. There's acid in the stomach. There's pepsin in the stomach. We have it breaking down the food into something totally different. It's going to look like milkshake. Remember that? Remember that's called chyme. So this definitely has to be a chemical change or a chemical digestion. Number 6, which two are part of the chemical digestion of the stomach? Pepto, hydrochloric acid, pepsin, or Pepsi? Now, you remember from the graphic organizer, it's pepsin and hydrochloric acid. Okay, number 7. The duodenum is a curved part of the small intestine that connects to the stomach. Which two chemicals are sprayed on the food as it passes through? So remember, this part is kind of like the car wash of the digestive system, where two chemicals are squirted onto the food as they pass through. One breaks down fats, one breaks down sugars. So if we look over here, amylase, which breaks down food into glucose, that's actually in our mouth, so no, that's not in our stomach. Insulin, which breaks down sugars, yep, that's one of the ones. The pancreas has a little tube that hooks to the duodenum that shoots insulin onto your food as it passes by, and it breaks down sugars. And then bile, which breaks down the fat. Yes, your gallbladder has a tube also in the same area, the duodenum, and shoots on the food as it passes by, breaking down the fats. All right, pepsins, no. Pepsins in the stomach, but not in the duodenum. So that's going to be our 2 answers. Okay, just 3 away. The small intestine absorbs the nutrients. Okay, that's all basically what digestion is about, digesting the nutrients into your blood. So most of the work, the main function occurs right here in the small intestine. What type of digestion occurs in the small intestine? Chemical digestion from insulin, bile that are still mixed with the nutrients. Makes sense because it's being put onto the food as it passes into the small intestine, so it's still got to be in the small intestine. So that's going to be our number 1 choice. Mechanical digestion from the churning of the stomach. No, that's not. That's before the small intestine, so that can't be the answer. And that's actually, no digestion occurs. That's ridiculous. So the correct answer is going to be chemical digestion from insulin and bile that are still mixed with the nutrients. Okay, 2 away. The large intestine is full of bacteria and vitamin K, which helps continue to break down the food. But one other thing happens here, so we don't have diarrhea every day. And if you remember, it squeezes all the water out and absorbs back into your body. Now, how do we get rid of this water that's absorbed into your body? You sweat it out, and when you breathe, there's always a little bit of moisture that's coming out when we breathe. You can test that on a mirror or a window. Just blow on it real close, you can see that moisture. All that moisture is coming from the moisture that was taken out of your large intestine. That's gross. Okay, I said it for you. Number 10, what type of digestion occurs in the large intestine? Chemical or mechanical? Okay, at this point, it's on its way out, and there's nothing else going on except moving it out. So we're talking about physical change, so that's going to be a mechanical digestion. And there we go. We are done. So we're not going to meet this weekend like I thought. I'm going to give you guys time off, and you can use Saturday and Sunday to review whatever you think you need to review. I've been kind of sneaking some of the things that we were going to cover Saturday and Sunday into what we've been doing. So don't worry, you can still possibly get at 100. And I'll continue to sneak some things in on Monday and Tuesday. And don't forget, Wednesday and Thursday is going to be our 2-day semester exam, 28 questions. And it's going to be exactly over all the stuff that we've been covering. And more of the questions are going to be what we have studied since Wednesday to today. All right, that's all for now.